Hello, my name is John Graves, and in this podcast, I'm going to be talking about the science and engineering practice of analyzing and interpreting data and teacher conceptual change related to this practice. If you have not had an opportunity to look at the podcast that I created on teacher conceptual change and the next generation science standards, I highly encourage you to pause this video and go back and take a look at that. A link to that video is listed in the video description below. The idea behind teacher conceptual change is built on a teacher conceptual change model, or in this case, a cycle, where we start with the beginning stages of building awareness, working through exposing our beliefs about a concept, confronting those beliefs, reinterpreting our beliefs, integrating our beliefs, and then eventually getting to the point where we are inventing our own understanding and have a full understanding of what's going on, and we're sharing our understanding conceptually with other people. A link to this diagram is also provided in the video description below. As I work through this podcast, you will see that I will be referencing certain stages along the conceptual change cycle relative to the pages that I'm talking about. Well, let's begin to build some awareness around analyzing and interpreting data. And a great way to do that is to go back to the framework book and read that brief description of analyzing and interpreting data. If you don't have access to the framework book, there's a link to a PDF version of it in the video description below. After you've read that brief description, I'd like you to go back and to identify the verbs in that description. What are students expected to do? This is a great way to build our own awareness around this practice by writing down those verbs, reflecting on what students are supposed to do. And if you have the opportunity to share your list of verbs with a colleague, I highly encourage you to do that. Once we know what students are supposed to do with the practice of analyzing and interpreting data, take a look at the nouns in the description and ask yourselves, what are students supposed to produce as a result of having mastery over this practice? So what does this look like, and how does this challenge our thinking? So we begin to expose our beliefs by asking ourselves reflective questions like, what are my current beliefs with this practice? And in what ways do I think I'm currently using this practice? And what challenges do I see using this practice in my classroom? And again, this is great conversation material with a colleague. I'm going to describe my understanding of analyzing and interpreting data, but I want to start at the end, the high school level, and work my way back to the primary level so we can see what the end result is, and we're going to work our way back. As I look at the description of this practice from a high school perspective, students need to be able to do the list of things that we see here. They have to have some idea of being able to do complex analysis, some statistical analysis. They have to be able to work with large data sets. That requires that students understand what normal distribution looks like. They have an understanding of what a typical bell curve is and what standard deviations are. And there are many activities that help students understand that, but it's important that when they take a look at a data set and they find the mean of a data set, and they have to be able to say, is this normal or is this abnormal? So they have to understand what normal distributions look like. Another thing that they can do is to begin to compare data sets. So in this particular diagram, on this table, there is a set of data for a fast plant that was grown under natural light and a fast plant that was grown under artificial light. Fast plants are actually genetically modified to grow under artificial light, and so there was a difference in the mean of the heights of plants grown under natural light and artificial light. So a question we could ask is there a statistical difference in those means, or do we just chalk that up to chance? So students have the opportunity to begin to learn to do simple statistical analyses. One of the tests that we can use is a t-test. So students will be introduced to using t-tests. Again, asking the question, about whether or not there's a difference of the means, and is that difference only related to chance, or can we eliminate the fact that it's related to chance and say that there is a statistical difference between those means? There are online t-test generators that are available, so a student can take one data set and place it in the population or group 1 category and put the other data set in the population or group 2 category, and actually let the website itself generate the results, and they can determine then whether or not there is a statistical difference between the means that they're looking at, and they can eliminate the fact that the result of those is because of chance. And then now they can say, in this case, with 95% confidence, that there is a difference and it's not related to chance. So there must be a difference between plants that grow under natural light compared to plants that grow under artificial light. Again, at the high school level, students will certainly engage in computer simulations. They'll deal with large data sets, some of their own generation. They'll generate those data sets themselves. In other cases, they may go out and find large data sets relative to weather, climate, populations, whatever it happens to be. Students need to have a full understanding of how to deal with those large data sets. This is a great place for me to talk about the cross-cutting concepts that are also included in the Next Generation Science Standards. So given some of the activities that I just shared, we can mention that there's a connection to stability and change. For example, the FAST plants demonstrate both stability and change through that growth process. What about scale and proportion? Those kinds of cross-cutting concepts can also be part of our discussion with our students. This is a great way to integrate your understanding conceptually of the components of the Next Generation Science Standards. So back to data analysis. At the middle school level, students are expected to display, to analyze, to interpret. They need to know how to graph. They need to begin to understand outliers and averaging, and be able to take care of measurement error. So one of the ways we can do that is engage students in graphical representations of data, and box and whisker plots are a very powerful way to do that. Again, back to the example of the FAST plants grown under natural and artificial light, you can see these box and whisker plots look very similar, but their means are slightly off. So it's a graphical representation of the data that helps students, again, interpret that data even more fully. Another example is using data such as Old Faithful eruption data, where when this information taken from an eruption, how long it lasts, which is called the duration, and the time between eruptions, called an interval, when that data is plotted, you end up with a scatter plot. And the scatter plot looks like this. You tend to get a pile of data points down in the lower left-hand corner and another pile of data points more up in the upper right-hand corner. And if you take a look at those groupings, find the average of each of those two groupings, you can actually determine that if there was a short eruption, then it will go off sooner the next time because there's less water being used up. If it's a longer eruption while it's going off and it's used up a lot of water during its eruption time, it will take longer for the geyser to recharge and go off again. And what we find out is that that time frame, and this is older data so it may not be true today, but when we did this a number of years ago, it was about 63 minutes for a short eruption and about 88 minutes for a long eruption. So students can then interpret this information and come to the conclusion that I just shared, that if the eruption is short, it's going to be a shorter time till it goes off again. If the eruption is long, it's going to be a longer time before it goes off again. And they can actually watch an eruption and predict when it's going to go again. Even if you don't have the ability to take your students to Yellowstone Park, they can look at an eruption off the Old Faithful webcam, predict when it's going to go off again, and then check their prediction against what the rangers at the park are predicting for the next eruption. It's a great way to help students take real data, put it on a graphing calculator, as a scatter plot, and then interpret that data. One of the things students will also do at the middle school level is to learn how to take data from tables to graphs. So the whole process of helping students understand what is a dependent variable, what is an independent variable, or what is a responding variable, and what is a manipulated variable. So begin to use those terms with students. Again, I'll reference back to cross-cutting concepts, that there are ways that we can then connect these concepts to some of the activities that I'm sharing, like cause and effect, Old Faithful eruption, patterns. You see patterns with a bouncing ball, for example, or patterns with Old Faithful eruptions. It's important that students are beginning to see the interconnectedness not only of the science and engineering practices, but also of the cross-cutting concepts. Now remember, I'm working my way down from the high school level. Now we're at middle school level. Next we'll go to the elementary level, and what are students expected to know and be able to do at the elementary level relative to analyzing and interpreting data. Again, they'll be graphing. They'll be recording observations, collecting data, making tables, but all the way through this, they're going to be engaging in inquiry. Simple activities like predicting the number and colors of M&Ms in a bag, and then they predict those ahead of time, and then they open the bag and actually count out how many M&Ms there are, how many of each color there are, and then students can begin to graph that information. Or elementary teachers do a great job of taking a pumpkin, for example, and opening it up and having students count the number of seeds in there, and then using the seeds to represent a graph. You can see both of these are pumpkin seed graphs. Elementary people do a great job of helping students collectively as a whole class create these kinds of graphical representations and interpret the data that's being collected. I highly encourage the use of science notebooks for students to record their information, their observations, and create data tables so that they have ready access to the information that they are learning. This is a connection to the science and engineering practice of obtaining, evaluating, and communicating information. Once you've gone through some of these activities, it's a great place to stop and reflect again about how these activities are changing your conceptual understanding of this practice, and how can you foster this understanding with your students, and what are ways that you can make this practice a part of every learner's repertoire. The Toolkit for Teacher Conceptual Change that's linked in the video description below has these and other activities in it that will help you understand and develop your conceptual understanding of this practice of analyzing and interpreting data. As I mentioned, I will always try to remind you of the interconnectedness of practices. So students, once they have analyzed and interpreted data, have an opportunity now to engage in argumentation around the data that they've interpreted. So there's lots of ways to connect the practices back and forth. So notice and be aware that this is often a seamless move from one practice to another as we go through this with our students. Again, I'll reference back to the Conceptual Change Cycle. Challenge you to take a look at where you are on this cycle as you work through your conceptual understanding of the practices. There's also another assessment tool available for you that's linked in the video description below, and I encourage you to use that as you are taking a look at your understanding conceptually of each of these practices. Thank you.